Okay, today we're going to look at section 3.2. We're going to talk briefly about polynomial functions. So, if we let n be a whole number, and a sub n minus 1, a sub n minus 2, all the way to a sub 1, a sub 0, be real numbers. Where a sub n does not equal 0, then the function defined by f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus all the way to a sub 1 x plus a sub 0 is called a polynomial function of degree n. So we've looked at quadratic, which would be degree 2. So let's look at some other ones here. Let's look at some concepts with this. First thing we look at is some terminology, such as x approaches infinity, and likewise as x approaches negative infinity. And then we also have as f of x approaches infinity and as f of x approaches negative infinity. So let's talk about something called the leading term test. So consider a polynomial function, again given by f of x f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 all the way to a sub 1 x plus a sub 0. As x approaches infinity, or as x approaches negative infinity, f eventually becomes forever increasing or forever decreasing. And we'll follow the general behavior of y equals a to the n, a sub n x to the n. So let's look at this. Now we have 4 different possibilities here. We'll start with n is even, and a sub n is positive. We're going to have a graph that may do something like that. Essentially a variant of a parabola, depending on what n is. Of course, if n is 2, we simply have a parabola. If it's 4 or 6 or 8, we'll have more wobbles in here. So if a sub n is negative, well, again, we're just going to go like this. And again, the number of wobbles will be determined by typically the exponent, what n actually is. Now, if n is odd and a sub n is positive, we're looking at this. And if a sub n is negative, we're looking at this. So note, with an even value of n, it faces, both of the ends face the same direction, either up or down. Whereas for an odd, one faces down, one faces up. One goes to negative infinity, one goes to positive infinity, negative infinity. So what are we talking about? Let's see. Let's start with f of x equals negative 0.3 x to the fourth minus 5x squared minus 3x plus 4. What is the end behavior? What happens here? Well, a is negative and the exponent is even. So I have even, I have negative. So the input is x approaches negative infinity, like this here. Okay, how about this one? I'm looking at g of x equals 6/7 times x minus 9 to the fourth times 3x minus 5. Okay, so now let's look at this. Eventually what we're going to end up with is x times x to the fourth times 3x. So we're going to end up with x to the fifth. We have a positive a sub n and we have an odd n. So we're looking at this. So we're looking at down to the left, up to the right. Okay. So now let's talk about finding zeros. So we have an equation or a function f of x equals 4x to the third minus 4x squared minus 25x plus 25. So to find the zeros, what does that mean? That means where does this function equal 0? If 4x cubed minus 4x squared minus 25x plus 25. Where does this equal 0? Okay, one way we can do this is factor. Here I have 4x squared times x minus 1. Here I have negative 25 times x minus 1, and this equals 0. Then I have 4x squared minus 25 times x minus 1 equals 0. This factors to 2x minus 5 times 2x plus 5. Bring down our x minus 1 equals 0. And to solve this, we simply set all this equal to 0. 2x minus 5 equals 0, or 2x plus 5 equals 0, or x minus 1 equals 0. Add 5 to both sides, 2x equals 5, x equals 5 halves. Subtract 5 from both sides, 2x equals negative 5, x equals negative 5 halves, and here add 1 to both sides. So I actually have 3 zeros. Okay, let's look at another one. How about this? F of x equals x cubed plus 10x squared plus 25. We want to know where this equals 0. So x cubed plus 10x squared plus 25 equals 0. I can factor out, yep, that's 25x. Sorry. So I can factor out an x. I get x times x squared plus 10x plus 25. Keep this x, and this factors to x plus 5 times x plus 5. So either x equals 0 or x plus 5 equals 0, x equals negative 5. And that is our zeros. So that's how you find the zeros. We've been talking about that in a sense. So that brings us to something called multiplicity of points. So we have this here where we factored it here. So this tells us that x appears one time, and x plus 5 appears 2 times. So this means the 0 for this particular is 0, and it has a multiplicity of 1. Whereas this 0, which is negative 5, has a multiplicity of 2. So that's what that term means. So let's look at something that has to deal with this. So if we let that f be a polynomial function, and let c be a real 0 of f, then the point C0 is an x-intercept. Remember, we're talking about 0 is where it touches the x-axis of the graph Furthermore, if C is a zero of odd multiplicity, then the graph crosses at C. So the point C0 is a cross point. If C is a zero of even multiplicity, then the graph touches the x-axis at C and turns back around. So it doesn't cross the x-axis. The point C0 in this case is called a touch point. So let's look at some examples of doing this and see what we got. So if P of X equals -3/5 times X plus 3 to the 4th power times 5X minus 1 to the 5th power. What do we have? Well, we have this X plus 3 4 times. So X equals, well, let's go ahead and show it. X plus 3 equal to 0. X equals -3. It has a multiplicity of 4. Whereas 5X minus 1, 5X equals 1, X equals 150, or 1/5. This has a multiplicity of 5. So what does this mean on our graph here? This means at -3, 0, it touches, and at 1/5, 0, it crosses. So this is a touch point, this is a cross point. Okay, what about this one here? Q of X equals 2X to the 6th minus 14X to the 4th. So we can factor out 2X to the 4th times X squared minus 1 at 2X to the 4th times X minus 1, X plus 1. So X equals 0, that's this here, right? As a multiplicity of 4. X minus 1 equals 0. X equals 1 has a multiplicity of 1. And X plus 1 equals 0. X equals -1 has a multiplicity of 1 as well. So this is even. So we have a touch point at 0, 0. And we have cross points at 1, 0 and negative 1, 0. Okay. Now we start getting to something. You'll deal with this a lot more when you move into calculus. Something called the intermediate value theorem. You may even get to prove this. And this says let f be a polynomial function for a less than b if f of a and f of b have opposite signs, then f has at least 1, 0 on the interval AB. So let's see. Let's apply this and see what happens. So what if f of x equals x to the fourth plus 6x cubed minus 26x plus 15. And we want to know, or we want to show that this has a 0 between -4 and -3. Somewhere between them. So the easiest way to do this, simply start with -4, find f of -4. Well, that's -4 to the fourth plus 6 times -4 to the third minus 26 times -4 plus 15. And let's do this. -4 to the fourth, positive 256. 6 times, oops, that's 6 times 64 minus 384, 26 times 4 plus 104 plus 15. So I have 256 minus 384 plus 104 plus 15. And this is -9. Okay, let's move this up here. Okay, so now let's look at -3. F of -3 equals -3 to the fourth power plus 6 times -3 to the third power minus 26 times -3 plus 15. So -3 to the fourth is at 81. This becomes 6 times -27 -162 -26 times -3 plus 78 plus 15. So 81 minus 162 plus 78 plus 15. And I get positive 12. So this is positive, this is negative. Yes, there is a cross point in the interval. Okay. The next idea we talk about is how many wiggles, how many turning points. So again, if we let f represent a polynomial function of degree n, then the graph f has at most n minus 1 turning points. So we can put this all together and graph a function. So let's graph something. Now let's go through this procedure anyways. So we have g of x equals negative x to the third plus 4x. So to graph a polynomial function defined by y equals f of x, use the leading term to determine the end behavior. Okay, negative. So I have odd degree and I have negative. So I'm looking at this. So let's see. Let's go over here to the side. And my memory is shot. Okay. To the left going up, to the right going down. So we're talking like this and like this. Determine the y-intercept by valuing f of 0, or g of 0 in this case, 0 plus 0. So we have 0, 0. Determine the real zeros of f and their multiplicities. So what? We have negative x times x squared minus 4. We have negative x times x minus 2, x plus 2. So here's this negative x equals 0, x equals 0. That's this one here. X minus 2 equals 0, x equals 2, 1, 2. That's his here. And then we have x plus 2 equals 0, x equals negative 2, 1, 2. This here. Now, we know they're all crossing points because the multiplicity is 1. So we have all this. We draw, starting with the left end, connecting to the x and y intercepts. So we know we're going to go something like this. And we know we're going to cross, and we know we're going to cross, and we know we're going to cross. This is something like what we're looking at. We can test it for symmetry. Not going to work. This is an odd function. The odd function, if f is an odd function, it's symmetric to the origin. Which makes sense. And so we're good. We can plot more points, so we can just leave it like that. Okay. They do another example in the text. I don't think we need to do that. You can always Look at that. That's all we have for today. I will see you next time.